Okay. So welcome everyone. I'm going to go ahead and get started today. I think that we still have a few people that should be joining us soon, but they probably won't miss anything other than introductions. So we'll just start off by talking about what we're going to do today. I'll introduce myself and then we will roll into today's lecture, which will be the Linux. So this morning we're going to look at Linux. We'll see the agenda here in a minute, and then this afternoon you'll be meeting Miss Nicole Cliff, and she'll be leading you through that topic for the afternoon. So we're going to switch over to our presentation now. So today is the 22nd of September. This is day one of our training. So who are we? Well, I got to introduce myself just briefly to everyone, but in case you have not met me or talked to me or had a class with us before, my name is Sarah Reese and I'm the director here for the Cyber Workforce Academy. So as the director for the Academy, we basically, me and the team here put together training. We look at what the trends are out there, and we're also instructors. So we're really dual-hatted. We don't just find the curriculum and create the curriculum, but we also teach the curriculum. Some of my superpowers, I would say, out-of-the-box thinking. I do love scuba diving. Memes are probably very close second as far as, my favorite things, cats, of course, being number one, which I think is appropriate since I'm a technology person. Many of us love cats. So that's just a little bit about who I am, but I served active duty military for 15 years as far as professionally, and I'm still in the National Guard with South Carolina, though, not Georgia. And I work as a network information security and network technician. So I was a 255 November by trade, but I've switched to 255 Sierra in the Guard and work there in a slot with a Army Air Missile Defense Command in the senior warrant slot there. So that's just a little bit about me. Again, I started as a network technician, but then I grew into security because what good is a network if it's not secure? So we'll go ahead and look at our agenda today. And this is just a reminder of the Georgia Cyber Range's URL. Have this on hand and be ready to jump into the range when we get to the end of this lecture, because that's when we will be starting up our lab. And I will stay with you for the beginning of that lab just to get everyone started, and then I will let everyone go on their own. I'll also do some demos after we talk through Linux as an operating system. That way you get an idea, and you can follow along with those or not, but that way you kind of get an idea of some things outside of what you'll see in the lab. So today for training, again, starting at 9 a.m. and then going until noon, we're going to be looking at Linux orientation. So our lecture will be anywhere from an hour to an hour and a half. I think we'll probably be more around an hour. And that will leave you at least 2 hours, an hour and a half to 2 hours to complete your Linux orientation lab. This afternoon, we'll return at 1300, and you will get a lecture by Miss Nicole Cliff. She will introduce herself, and she'll be going over alerting and traffic analysis. So during that lecture, she'll be looking at Snort as well as TCP dump and Wireshark. So we'll go ahead and get started with our lecture today, or this morning, for Linux. So before we start really talking about the details in Linux, we need to talk about what Linux is. It is a free operating system, and it closely resembles Unix. Now, oftentimes Unix and Linux are really, they're referred to as in the Nix family, N-I-X, so in the Nix family. This is because both Unix and Linux were built upon the POSIX standard. So that's something that if you're interested in trivia and you want to go look it up, POSIX standard is the standard at which, Linux and Unix were developed from. Unix, of course, being proprietary. The big difference with Linux is while Unix is much like Windows, where you have to pay to use the operating system and for support with that, and much of the kernel operating system code is closed source, Linux is totally free and open source. This means you can see all of the code. It's all out there in the open. It can be worked on collaboratively. You can alter it yourself. So It's a very powerful operating system. And as far as why we're talking about Linux, there are probably many of you out there today that don't use Linux on a regular basis. And some of you probably do. But I'll tell you, even if Linux is not something that is in your, library of skills yet, you should definitely consider making it one of your skill sets. Linux is not only a very powerful free operating system, but I would say anywhere from 80 to 90% of actual internet backbone services and those types of things are run on Linux servers. Linux is one of the most popular operating systems for your backbone type services. Now, when we look inside of enterprises, like many of you work in, enterprises often revert to the Windows operating system. So you'll see Active Directory and you'll see IIS as a web server, and you'll see those types of things. But again, when you go out to commercial websites, you go out to the backbone, oftentimes you have a lot of these services and sites being run off of Linux. Furthermore, as a security professional, there's a suite of tools that are available specifically through Linux. Most of the security-centric type of operating systems that come bundled with those tools are going to be on Linux. Good examples of those would be Kali Linux, and this is a distribution that was based on the Debian kernel with some modifications and is preloaded with basically every ethical hacking tool you could imagine. This is something that's used by folks to do vulnerability assessments as well as penetration testing. And so that's the offensive flavor. And on the other hand, we have Linux as an operating system being used in Security Onion. And Security Onion, if you haven't heard of this, it is, again, a free open source operating system based on Linux and Ubuntu that is bundled with a number of defensive cyber operations tools, to include the capability to collect logs and alerts from sensors, deployed sensors, parse that and ingest that, and provide that to a SIEM system, which is something that Nicole will touch on this afternoon. So again, having Linux skills is going to be incredibly important. Now, as far as when you work inside of Linux, one thing that many people have a misunderstanding about with Linux is they imagine, when you say Linux, they imagine this command prompt, just this black prompt, and it's command line and you're typing away and that's all you see. Well, Linux operating systems can be command line only, but they can also have graphical user interfaces the same way Windows does. Now, the reason why you may not have a graphical user interface on a particular Linux system is because that graphical representation and interaction through a mouse and things of that nature do take up resources. So if you have a machine that you need high performance on, for example, it's providing a very specific function in your organization, you want to dedicate as many resources as possible to that function, especially if it's not something that is going to have excessive user interoperation on it. When we look at our desktops, like the computers you use every day, these have a high level of user interaction. So we do want to see GUI or GUI, graphical user interfaces, on those types of computers. But if we're talking about a server that simply provides a service and needs resources dedicated to that, oftentimes you'll see those installed without the GUI. And this is true of Windows as well. Windows Server can be installed without a GUI, where all of the management of that system is done through PowerShell. So again, if your apprehension or assumptions about Linux are that it's hard because it's CLI, just keep in mind that not all Linux systems are exclusively CLI, and working inside of a CLI environment is a good skill to have, because it's going to allow you to interface with systems that have dedicated purposes that need to reserve those resources for those purposes. Now, one thing I will touch on before we move to the next slide is when we are looking at Linux operating systems the same way as Windows operating systems, I'm sure for any of you that are familiar with Windows, you've opened up a command prompt and gone ahead and looked at the IP config, for example, to get the IP address of the computer. Well, that command prompt is inside of a shell, inside of a terminal. When we're talking about a Linux operating system, the same as on a Windows system, if it has a graphical user interface, which means a nice desktop, you can use the mouse, you have shortcut icons, You can open many terminals, as you may recall from yesterday. However, if you're working in a CLI-only Linux system where you have not had a GUI operating system or a graphical operating system installed, this means that the terminal into it, the virtual terminal line that you have connected into it with via SSH preferably, would be the only terminal line that you have. You don't have the ability to spawn more windows. The windows are controlled in that graphical mode and allow you to have multiple terminals open at once. That doesn't mean that you can't SSH into the same server and have multiple terminal sessions open, but that would be something that would be distinct from the position you're on that you're using to interface with that server. So we'll go ahead and move on. So again, I kind of touched already on the graphical-based versus the text-based interfaces as far as using Linux. Now, what we're going to be focusing on here is using the Linux CLI. And that's because, as you saw yesterday, where we had an Ubuntu VM that you'll be using for your labs, an Ubuntu VM looks pretty much like a Mac desktop. In fact, you might be able to fool some people if you threw the right background up and tweaked the icons. So, using a Linux machine with a GUI graphical desktop is something that is very comfortable, and it's a great way to expose yourself to Linux and start to get more comfortable with the operating system. So that's what we'll be using throughout this particular training session for the next 3 days. So we'll have to focus on using the Linux CLI because this is really where you're going to interface directly with the operating system. So when you're interacting with the operating system, remember that this is really the same type of thing as what you're doing when you're clicking on a shortcut icon to open Firefox. I can issue a command in the terminal, and the command is just Firefox, and that will open a web browser in the same way that double-clicking on an icon will. The difference is that I'm going directly and giving that command directly to the operating system through that terminal window, as opposed to, again, using that graphical user interface and the shortcuts. So as we're going through different CLI type commands and we're exploring the operating system, you need to understand that there's a basic format when you're issuing commands in a Linux CLI. So you're going to have the command, and then you can have a series of options. This would be something where you could add some particular filter or some particular thing that you wanted to specify to that command. And then you'll also have potentially a list of arguments. This could be, for example, if you were taking a command and running that against something, or you have to pass the command a particular item to take an action on. So an example of that could be when we look a little bit further in these slides, we'll look at, for example, the telnet command. There are options that you can use, but when you use the command telnet, you also have to give it an argument of where are you telnetting to, where are you going to be, opening this session to, or SSH, for example. There are command options for SSH, and then there are arguments, meaning, what am I SSHing to? So again, your options, these are going to change your behavior. Arguments are going to provide additional information such as, where you're going to or what you're taking action on. Now you'll see at the bottom of the slide here that we have an older and a newer format. So just to familiarize you with the lingo, if you haven't heard it before, where you see the dash in front of the A, you'll hear that referred to often as TAC A. So TAC A, we just mean TAC is that dash. So TAC A would be an option that would specify all. For example, if you use the netstat command to look at network statistics and connection information, you could use TAC A to display all connections. You could also filter this in a different way, and you could use TAC T, for example, with netstat to look at only TCP connections. This means you would not see Linux sockets or UDP sockets. You'll see underneath that you have a newer format. This is going to be TAC-TAC. So you see 2 dashes followed by a full word. Oftentimes, depending on the type of tool and how often you interact with it, your TAC-TAC all may be easier for you to remember because the command itself is going to be a full word, a more descriptive way to understand that option. So either of these are generally going to work. And it is important that you know for the older option format where you have one tack, if you have multiple different options that you would like to introduce to that command, you can actually compress those using one tack followed by all of the options. So I'll give you an example when we talk about netstat. I like to use that example because it's one that I always use with options. When I use the netstat command, I could say tack A and T, which would give me all of my TCP connections, and it would have no name resolution attached to those. So it would just give me the pure IP sockets. So when I do that, I don't have to write tack A for all, tack T for TCP, tack N. I can actually compress those into just one tack and then the list of all of those options. So again, don't get wrapped up too much in this. We will go ahead and see some of this when we get into our lab, and I'll give you some examples when we start our demo. All right, so if everyone wants to jump into your Linux machine, if you can access your Georgia Cyber Range account at the URL, you should have tried to access this yesterday and notified our range director if you had any issues with logging in so that we can rectify that. If you have issues today with logging in, please send that email, and I'm sure that was in the chat yesterday, and we can make sure that that is available to you today as well. But once you've gotten into that particular environment on the range, log into your Ubuntu VM. And yesterday I forgot to tell you that the credentials are GTA_user. That will be the default user. You should see that user already there. When you click on that to log in, your password will be GTA_pass. Once you have logged in, I would like everyone, if possible, just to open a terminal window. You probably saw us doing this yesterday in our demonstration. This is going to be in the lower left-hand portion of your screen. It will be a small black icon, a box-shaped black icon with a white $sign in it. If you click on that shortcut in the lower left-hand corner, you will see a terminal window pop up and appear. So we're just going to get prepared, and I want you to have that up so that as we start talking about these different commands, if you would like to, you can go ahead and put those in yourself. You don't have to. If you would like to just listen to the lecture and then try going in afterwards, rewatch the lecture, that is absolutely fine as well. But I'll give everyone a chance to open that terminal in case you would like to follow along and try some of these commands as we discuss them. So a few things that I will mention before we start talking about commands or playing with commands is that if you get into a situation where you don't know how to get out or something is stuck running, you can use the Control-C option in order to shut that process down, basically break out of whatever you started that you want to stop. So that is a quick way to exit out. Other types of applications may use escape, and then you'll have other applications which we will mention and demo towards the ends of this lecture that will actually give you directions at the bottom as far as how to exit or save your work. So Nano is a text editor that you will use inside of your terminal, and we'll show you specifically how that one works, and I'll point out where the instructions are on the bottom of that terminal as to how to exit out of that particular program. But first, we're just going to talk briefly about getting help. So man is a command that you can use in order to find the man page, which stands for manual page, of any different type of command or program inside of your Linux operating environment. So anything that is currently installed and usable inside of your operating system is generally going to have a man page. So you can do man and then the commands that you'd like to invoke, and you will see the manual pages for that particular command or application. So that is something that may be useful to you, but I will say that the man pages are generally very long. So knowing what you need from the man pages is going to be important. And a quicker way to get information is to use the what is. You'll notice that's at the bottom. This is used to get just a one-line description out of that man page. Rather than having a 20-page manual come up to scroll through, you can actually look for just a one-line description of what that particular command does. Which is another great command that you can use inside of the operating system. Which is going to be something that you use to locate executable files. Now, the reason why this is important is because when we talk about executable files, imagine these as some sort of application or program. So for example, Firefox is an executable. It's going to allow you to execute a program. There's other types of executables. For example, if you have Nmap installed, which is going to be used for scanning. This particular executable would be something that you would invoke to do a vulnerability assessment. Now, whenever you are using the CLI and you execute some sort of a command like this, what's going to happen is the terminal is going to look in a set of, the terminal is going to search your environment variables. They're going to search all the paths that are set in your environment variables. What this means is it's going to look for the location of that application. So rather than clicking on a shortcut on your desktop, it actually has to parse the file system from the terminal to find that particular command, that particular executable, and run it. So it's going to start by looking in the home directory. The directory that you're, not the home directory, but your current directory. So it's going to look at your current working directory. It will look at your home directory. It will also look at a number of other default paths that are going to be assigned to your environment. Now you can add paths to your environment if you have installed a executable in a location that is not necessarily a part of your default path. So this means you've placed it in the operating system somewhere odd that isn't somewhere that executables would generally be located. This isn't something that you'll have to worry about for the context of this class, but understand that if for some reason you know that something has been installed on the operating system, but when you go to invoke the command, it doesn't seem to recognize it, you can use the which command to find the directory it's located in. Then if you invoke that command with the entire directory path, it will be able to run it. Or you can move to that directory or look at moving that executable or adding the path, adding that particular directory path to your environment variables. And then I will mention help. TAC-H or TAC-TAC-Help are going to be great ways that you can get a basic, very, very brief description of how you need to use a command. So for example, if you don't know the options and arguments that you need in order to use the SSH command to SSH to a particular device, then you can use SSH TAC-H or SSH TAC-TAC-Help. And this will give you usage of that command, help about the usage of that command. It will generally list most of the options and arguments for that command and let you know what they do. So help is extremely, extremely useful to understand usage and options and arguments for your different commands that you'll be issuing. All right, so files and text is what we will talk about next. And before we talk more deeply about a couple of these commands here, I do want to describe something to you that is a very interesting thing that is very, most people that have worked around Linux have heard this a time or two. So there's a saying that goes that everything in Linux is a file. It's not entirely true. Everything in Linux is an object that looks like a file. And so this is something that's distinct from Windows. If you imagine in your Windows operating system, you have things such as your registry settings. These registry keys are understood as registry key objects, versus in your Linux operating system, basically everything, to include even the processes that are running, are used or are used, accessed, and represented as files. They have file descriptors in order to locate, access, and manipulate them. So while it's not necessarily fair to say that a process is a file, a running active process is represented as a file with a file location and information contained in that location. So it's just a way of representing information different than what you see in the Windows operating system. Now, for this reason, because everything is represented as a file, again, to include things like processes or even registry settings, which again, on the Linux operating system, we're not calling them registry settings, but we would call them kernel settings in this instance. So everything is being viewed and treated as a file, which means that we have to be fairly comfortable with using or manipulating files or finding what's in them. Basically anything where we are manipulating or looking at files and text. So a couple things that you should be aware of. The cat command is one that you will use very frequently. Cat is going to be a standard utility that's always going to be present on your Unix, Linux type machines, and it will read files. It will read everything in the file and put that in what we call standard out. Now, I will mention standard in and standard out later when we get into the demo, and I talk to you a little bit about Linux pipes because that is a very important thing. But when it reads this, understand that it reads exactly what it sees. If you were to cat a file that is represented with text, such as in this example, you'll see cat, and then the directory location /etc gives you the directory, and then /password is the file. The cat will actually read everything in that file, which happens to be text. If I was to cat something that was a binary and an executable, this particular thing may be in a compiled computer language, and therefore I may not see it represented as text. So what you cat needs to be something that is text if you want to be able to read it. Otherwise, you'll see a lot of symbols and things. But in your Linux operating system, again, most of what you will interact with and everything that we'll do within the context of this course will be text-based. So cat would be a command you could use. You can also use the more command, M-O-R-E, or less command, and you're welcome to explore those, and you'll see those when you get into your Linux commands lab. But the more and the less command also give you the ability to go through text. They give you a paging ability, which means that while cat spits everything out at once and you have to scroll through it, if you are working with a terminal window on a desktop, that's fine because you can scroll. But if you were to be SSH'd into something, then you would not be able to scroll. You would just have that, you would be, or I shouldn't say SSH, if you were in a command line only environment where you don't have a terminal window and you can't scroll, you would want to use more or less. Either of those commands give you the paging ability where it will only spit out a first page, and then you'll have to press the enter or the space key to get a line or a page next. So grep and egrep are the other commands here, and then I will kind of talk to you about how that example command at the top will be read and treated. But grep or egrep, which is extended grep, is basically a default tool that will be on all your Unix, Linux systems that will be used to search for anything. This can be used to search for text strings, but egrep can also be used to search via regex and different types of symbols and things, depending on what you're looking at. So when we're using grep or egrep, this might be a way to search for a particular string so that I don't have to read the entire configuration file or read the entire password file to find that particular item. So if you look at the very top where you see the example of the text manipulation command, you'll see cat, which again will spit out the information, and then you'll see etc/password. This will be the password file located in the etc directory. Now what you see next to that straight up and down line, that is what we call a pipe. So a pipe, and that symbol is going to be on your keyboard, it's going to be the uppercase over your return, carriage return. This particular pipe that you'd use in a command line in this fashion is what we call a one-way pipe, meaning the standard out based on the cat command. So that's whatever gets spit out into your terminal window, which is standard out. Standard in would be what's read into input from your keyboard. So whatever is spit out in standard out, that pipe is a one-way directional basically a path that takes the standard out and feeds it to the next command. So we take the standard out of cat, which will spit out everything in the password file, and we feed it to the egrep command to take action on. So now, based on that standard out, or based on that information that I see in that file that Kat is showing me, seeing that text, I'm going to grep or search for something in particular. In this case, I'll be searching for the word root. Now, I could just use grep instead of egrep and use root without the quotes, because grep will automatically only look for ASCII string characters. With egrep, you are able to support different things like regex patterns, and so this includes additional options. I would say for this course, if you're not comfortable with Linux, if this is a first time for you, just use the grep command and type the word following it. But if you would like to experiment with egrep because you have some experience in Linux, it's a great enhancement to that tool. So basically what we see here is that the standard out, meaning the information in the password file, is being searched for the word root. And then once we find, or if we find, that particular string inside of the standard out for password, grep will show us that information. So the line that includes, or any lines, if there are multiple lines, that include the word root will then be shown. Depending on your operating system and your terminal settings, sometimes operating systems are set, which I particularly like, to highlight the word or string that you asked to search for. So grep will actually highlight that. So rather than just seeing this, output of the line, it'll be the line, but it'll also highlight specifically what you were looking for. All right, so moving on, we need to look just a little bit at remote access. So this is when we are wanting to access any system via CLI. So we've opened a terminal, or we're in a terminal-only session, and we want to access a remote client. Now we have two ways we can do that, Telnet and SSH. Obviously, Telnet is not something that you should be using. This is legacy, and it is something that only, it supports unencrypted passing of traffic. So everything you send or receive over Telnet is going to be in clear text. Obviously, from a security standpoint, that's not a good thing, because everything being unencrypted means that your username and password is in clear text. So if there was someone on the network listening to that conversation, all of that would be captured. Now, the reason that we still talk about Telnet today is because it is in fact used oftentimes, because legacy devices, applications, things of that nature may only support Telnet in some instances. When this is the case, we need to make sure that Telnet is being run over some other type of secure protocol. So for example, running Telnet through an existing IPsec tunnel or some other means of encryption would be recommended. But we will use Telnet in labs during this course so that you can see the issue with Telnet, as well as practice with traffic manipulation, traffic analysis. So again, that particular command would be legacy. You'll see in the example there, using that command, you would issue telnet, which is the command, and then your target for this command would be where you're trying to access, or telnet to. This will be using port 23 in general. That is the default well-known port, although it could be run on a different port based on the way that you set it up on the other side where the service is running. But when we telnet to that, the response from the target is going to be a prompt asking for our username and password. If we successfully put in a username and password that are recognized by that remote system, we will be able to gain shell access or CLI access into that remote system. Now, SSH is different. It is, again, still a terminal emulation system, and it enables you to connect to a remote host or device, but in this case, we'll see all of our traffic encrypted. So this would be preferred to Telnet. This is something that's going to run over port 22 generally. That's the well-known port, but you can change SSH, again, wherever that service is running, you can change it to use a different port if you wish. Generally, when that is changed to another port, whether we're talking about Telnet or SSH or any other application, when we change those to other than well-known ports, we're usually going to be using higher range registered ports as an alternative. Now, all that traffic is going to be passed encrypted, so this would be the preferred way to access a device remotely. But you'll see also that in the example command, it is a different command structure. I don't just in general issue SSH and then the IP address. If I am doing a username login password, I need to issue SSH, the username that I want to access that device with, at, and then the target. Now, if I'm using certificate-based authentication, which is supported in SSH, I do not need to put the user information there. But for the purposes of this course, you will only be working with SSH via username and password rather than based on certificate authentication. So again, you'll see SSH is the command. Root in this case would be the username, but you would know the username based on whatever your lab or your particular task would be. So the username could be John or it could be Ubuntu. So whatever that username is that you're trying to log in with, at, and then the target IP of the device you want to log into. Once this command is issued, what you're going to get back from that server, assuming it is in fact reachable, is going to be a prompt asking for your password. All of this will be passed between these two endpoints encrypted, so that password will not be something that can be sniffed or otherwise captured and read. Now, it's important as we look at these two commands, telnet and SSH, that you just remember from an operational standpoint, if you have trouble connecting, I would always go back and just check connectivity to that device, because in general, if you can't reach that device via ping or some other sort of utility, then SSH and telnet will also fail. All right, so now we're going to take a look at web interaction or using web-based tools from a CLI environment. Now, we mentioned Firefox earlier. Most of us have used Firefox, Safari, Google Chrome, a host of other browsers that are out there for our web browsing. So that's not something that's new to us, but generally when we interact with these, it's because we have a desktop, a graphical desktop system to interact with. So we open that browser, we give the browser a URL, and then we're able to get the information back via HTML, perhaps some JavaScript for interactive types of things, but we get all of that back in that graphical window. But what do we do if we're working inside of a shell terminal or a CLI-only machine? Well, it doesn't mean that we can't interact with web. It only means that we can't interact in a graphical format. So this means that we still can interact. So there are some tools that you need to be familiar with for interaction. These are going to be useful just holistically as you work through more advanced interactions on networks and workstations and systems, and as you work more in your CLI-only environment. So wget is the first, and this is a much simpler type of utility than curl, so we'll talk about wget first. Wget is the command that you would invoke, and again, I will demo this towards the end, but wget is the command that you would invoke, and then the argument for that command would be the, for example, website that you're trying to access. So you can say wget https://google.com, for example. This will be able to reach out to that site and then pull down a a text-based file copy of the web page. So as you know, on your web servers, every page that you interact with or visit is in fact a HTML file. Again, it may include some CSS, JavaScript, and other different types of utilities. But when we use wget, we're going to pull down that raw HTML file and the information in it. We can then look at that file and the information in that file in our command line terminal. Again, we don't see a graphic representation of it, but we are able to see the full text of what that particular website is displaying. Now, wget itself, it does support HTTP, HTTPS, as well as FTP. If you wanted to use it for FTP, you would just need to specify this protocol the same way that you would specify HTTP or HTTPS. Meaning, if you wanted to pull down a file from an FTP server, you would do wget space FTP : the name, if there is no name resolution, or the IP address of that server, the file directory and file name that you're trying to download. So wget would be able to pull that file dynamically from that FTP server. Curl is another command that is going to be installed on many of your Linux to Unix based operating system. And if it's not, it is a great item to install, but curl is a little bit more robust than wget. Curl also works for HTTP, HTTPS, FTP, but it also gives you the ability to interact with a number of other protocols, things like LDAP, RDP, so there's a whole host of other things that you can do with curl. So curl is something that, again, for the purposes of this class, we will use just for HTTP or perhaps FTP interaction, but curl itself is more robust and the one that I would recommend because it allows you to transfer data, either pull or push data under a host of different protocols. And curl's syntax would be much the same as wget, where you would type curl and then simply the target HTTP or HTTP site, HTTPS site that you would want to pull the file from. All right, so again, applications from the CLI. I talked a little bit about these. As we talk about applications, things like Firefox, Featherpad, and Wireshark are the types of applications you will use in the labs throughout this training. These are going to be graphical-based tools. We're going to be using these because once you see this afternoon with Miss Nicole Wireshark, if you haven't done traffic analysis before, it's much more fun with Wireshark as opposed to TCP dump. Now, there are certainly instances where you would prefer to use TCP dump over Wireshark because anything, again, just remember, anything that is graphical in nature is going to take more resources in order to run. And it does require that graphical desktop. Featherpad is a particular notepad type application that is present on your Ubuntu machine. So we'll introduce you to Featherpad. Again, it is just like Notepad, but we're going to introduce you to that because you'll be using that in some of your later labs in order to view and or edit configurations or text files, programs, things of that nature. And then we'll also demo at the end here a CLI-based text editor. So in the case of some of the labs where you do not have access to the host operating system and Featherpad, which again is like Notepad, you can use Nano. Or if you just prefer to use Nano, that's fine too. Nano is going to be an application that you use from inside of your terminal through the CLI in order to edit text in a particular file. And Nano is the more common, popular used one. VI or Vim are also commonly used CLI text editors, but Nano is much more user-friendly, so most people prefer to use that, and that's what we'll be demoing and using for this course. If you happen to love VI and you want to use that, then we won't tell you not to, but we recommend, especially for beginners, that you use Nano. All right, so that just closes everything that we're going to talk about in the slides. Now I'm going to go ahead and pull up a Linux, the Linux operating system that you're going to be in, and I'm going to demo some of those commands and talk about a couple additional things before I set you loose to do your Nix commands lab. And I will walk you through setting up that lab before we go off live so that you do have that information. All right, so you can see here I have my desktop. Again, if you have not logged in yet, it's going to be GTA_user, and then the password will be GTA_pass. These are all lowercase. Now, as we mentioned yesterday, these numbers down here, 1, 2, 3, 4, these are actually your desktops. Please do not touch those, because when you switch to another desktop, unfortunately, because this interface is being pushed through a web browser and certain commands are going to be confused by your host operating system and won't be passed directly through, the hotkeys in order to get you back to your home desktop are not going to work. I tried to make it work yesterday. It simply does not go through this particular console. So do not touch those numbers. If for some reason you do by accident touch those numbers and you find yourself on a different desktop, basically you can still do anything that you have still open in the windows, but if you needed to pull anything up new or access your start bar or any of your shortcuts, you would want to restart your computer. Once you restart your computer, then not your computer, I'm sorry, you should restart the VM. Once the VM is restarted, it will start back up on your on your number one desktop, so your home screen. And again, before I start, I'll just take you back over to this tab and show you that if you do need to reboot a VM, say it locks up for some reason, or you've navigated to one of those alternate desktops by accident, if you click on this button right here at the far side where it says Create Snapshot, and you scroll down to the soft or hard reboot, I always like to do a hard reboot. You can just click that, it will restart it. Once it has finished rebooting, you can log back in. So again, here we are at the desktop. Now I will just open the start menu that you see down here where this little bird is in the lower left-hand corner. If you want to access Firefox, you can do so from right here in Internet. You'll also see I have Wireshark, so we have that installed here. So if I wanted to open Wireshark, I could do so like this. I can also use Featherpad right here, which is a notepad system. Now, each of those can be accessed here the same way you would access something in a Windows GUI environment. You just find the particular program, or we can use a terminal to open them. So you'll see here that I've opened up a terminal. Now, if I wanted to open up from this terminal, I wanted to launch a browser, a Firefox browser, I simply type the word Firefox because that is the application, therefore executable. I press enter, give it a few minutes as it finds that executable, and you'll see that my Mozilla Firefox browser has deployed. So, again, very easy to do so from here. Now, you'll see I closed it out. The actual application is going to be tied to that terminal window. So if you close out that terminal window, it's going to close out the process that's controlling that particular command. The only way to get around that is to what we call background the command. So if we type Firefox and then the and symbol, and I'm not going to do that here, but if we do, well, sure, I can do it here. You'll see that what it does is it still opens Firefox, but Firefox is no longer tied to the life of this terminal. When I background it, it gives me here a process number, and then it backgrounds this so that I can actually close this out and kill it independently of the terminal, or kill the terminal independent of this. So you'll see after I close that Firefox, it's given me a done signal, so it has closed out that process, okay? So again, that would be example of how you'd open up Firefox from the command line, and you'll see this in your Nix lab. You can do things like ls. This will list all of the items in your current directory, and this will give you the ability to move from different locations, or rather to see different locations that you may move into or different files. You'll see here this item here, Labtainer Student PDF. This is in green. This is a file that you can execute and look at, versus these items in blue are directories. So when we say directories, this is synonymous to a folder in Windows. So you would put files into a folder. Well, in the folder location that I'm at currently, I have one file and then several folders that I could dig into and see the files within each of those. You'll also notice, you see here it says desktop labtainer-students. That is what we call my present working directory. If you ever get lost in your Linux directories and you want to check that, pwd gives you your present working directory. Now this home GTA user, this is going to be your default home directory. and then it was this terminal was set up to automatically go into this particular directory structure from home. If I wanted to go to home, if I wanted to go to my user's home directory, I can simply use cd ... to back up a directory and do that twice, or I can change directory to this little symbol here. The little squiggly symbol, that's going to be right underneath your escape key. That will take me directly to my home directory. You can see that I don't have an additional directory path here, and if I do pwd, you can see I'm in my base home user directory. Now, when I do ls here, again, to list what's in this directory, you can see I have desktop, downloads, documents. So again, this is just like the file structure you would interact with in Windows. And if you wanted to see this particular information in a graphical user format, you could simply go here to the Windows-based file viewer in the same way you would do inside of your Windows environment. If I go to GTA User, you'll see here I see the folders, desktop, documents, downloads, the same as I do in my command line. Okay? So if I was to click into desktop, I would see anything that's on my desktop. Here, to navigate to my desktop, I would use cd to change directory, and then desktop. Okay? Oops. Close that. All right, so a couple other things I wanted to go ahead and demo before we go further. We're actually going to cd to root. You'll see now that if I look at my directory listing, I'm at the root directory. So this is the very top, the very root of my file system. From here, I'm going to go into my etc directory right here. So I'm going to say cd etc. Now you'll notice that I see this directory appended as part of where I've navigated to. Now if I do ls, you're going to see a long list of items here. So you'll notice that because I am in a terminal window, if I want to, I can scroll up and see more of these items. But that's not very convenient. So what I want to do is show you that more command, which becomes very useful. I'm going to do ls, and then whatever the result of ls is, the standard out, which you saw was a big blob of information, I'm going to pipe that, so send that standard out to the more command, which will allow me to page through it. So now you see that I have a list, and I have this more down here where I can use enter to go line by line, or I can use a space bar to go to a whole nother page. So that just takes me a page down versus line by line, page, line by line. To exit out of here before, if I find what I was looking for, oh, I was looking for Firefox, that was the executable I was looking for, I can Control-C to escape that. But for the purposes of the demo, I'm going to use clear to go ahead and clear off my terminal window. That's very useful. I'm going to go ahead and cat the etc password file. Now, because I'm already in the etc location, I do not have to specify the /etc. I can cat the file itself if it exists. Oops. So you'll see here when I use the grep command for the PSSWD, the password file, you see how it highlighted these in red? That's letting me know that it did actually find those listed. Now again, you'll notice this is just like in our example, we did cat etc password, so this is everything that is in that file. Now what this is information about all of the user accounts and it's not their actual passwords, but it's the information about the password and access to the system. So for example, when you see these items that say no login, this lets me know that for this particular system, or I should say application-based user, that there's no login allowed. So you can't use games, or you can't use sys or bin to log in remotely via SSH Telnet or anything of that nature. It lets me know the location and a number of other things. Now, again, Etsy password is not the actual, this is not going to contain all of the actual clear text password information. You'll see here that we have X's, but again, this is just a file that we're using as an example. It has information about the accounts. The Etsy shadow file would be where you actually see the hashed password information. The Etsy password is just the account information. So we're going to use this, we're going to clear our screen, get rid of all that gobbledygook, and we're going to look specifically inside of this file using our pipe for something. So we're going to grep, and I know that games, well actually I know that GTA_user should be a user on the system. So let's go ahead and see if we can find the account information for GTA_user. So we're going to look in this file and we're going to grep for GTA_user. So once I do that, you'll see that it highlights in red anytime it finds the string that I specified. And you'll see information. This is the user SID. So that's going to be the ID that's given to the username. This is a placeholder. Again, you will not see the user's password. You will only see that placeholder. This is the home directory for that user. Okay, so we know that to be true as we checked our home directory earlier. You can specify different home directories when you set things up, but this is just default. And then here you'll see this is the default shell for login. So if you were to log in remotely via SSH or Telnet, you would be given a bash shell. So you see that bin is going to be the directory location, bash is the shell type. You could also see bin cbash, you could see bin, all sorts of other different shell types, just depending on the environment you're working with. Bash itself is a shell type that's most commonly implemented by default in your Linux, Unix-based systems. So we're going to clear that real quick. And we'll go ahead and try wget as a command. So again, with Firefox, if I wanted to go to Google, I would open up a Firefox browser and go to Google. But rather than doing that, I'd like to do wget, and I'm going to go to Google. So you'll see it's just wget and then the URL of where you're trying to reach. You'll see here, oops. I am in the wrong directory to be doing this. I'm sorry. Let me cd. I'm in Etsy where I don't need to be writing stuff because that is not what belongs in Etsy. So let me go back to my home directory. Okay, so you'll see I'm in my home directory. I'm going to go to my desktop so that you can see this file pop up as I pull it. And there you can see it is case sensitive. All right, so now that I'm on my desktop, if I do an ls, you'll see the stuff that I see here. Now I'm going to issue the wget command, and I'm actually using, you can't see it because you can't see my keyboard, but I'm using the up arrow. This will actually scroll through your history of commands until you get to the one you want to access. I'll show you another nice item, and again, you'll see most of this in your Linux command lab. If I type history, it will give me a by number list of all the commands that I have issued, so you can figure out what has been happening. So I'm going to arrow up and pull back up my wget command. Okay, so now we have a item. You'll see here index.html is what it was saved as. And it popped up right here. You'll see that's the icon. So if inside of my terminal I look, I can find index.html, and I can look at that file using my cat command because I know that file is HTML, so it's just text. Oops, index. So you'll see that there's a whole bunch of stuff going on here that you really wouldn't want to read, but it is human readable information. Okay, so again, you see all of the information, and this is not formatted, you know, as you would see in a any type of a notepad or code-based program, but you'll see document type, HTML item scope. So this is all the information about what's on that page. This, of course, will be rendered into a browser rather than read manually in this nature. But this is, you know, an example of a page that has a lot on it. Other pages may be much more simple. You can again see that this has some JavaScript and interactive things in it because obviously Google's homepage has a search bar. If we go over here and we look at this file that we pulled, I went ahead and double clicked that, and this is what it's going to do. It's going to render this into a browser, okay? So you see that basically it's not the online version, it is a graphical representation of an offline version of this particular website. So I could use this to pull things in and then look at them locally, okay? Pretty neat. All right, again, clear is going to help you clear out that terminal so that you can see what you're doing again. I will use IP address. Oops. This is going to be, as I showed you yesterday, the way that you can see your IP addresses. Okay, so you'll see here 1, 2, 3, those are the adapters. Loopback, every computer has a loopback address. ENS3 is going to be the adapter for the host machine we are on. This is the IP address for the machine I'm on. You'll see here number 3, I have Docker 0. This Docker network is going to be specific to your Labtainer lab environments, and so you need to make sure that you, that's not something that you mess with. So that is not your IP address, and you will see further items if you actually spin up Docker containers. You will see more networks populate here as those Docker containers need to populate their network space. Now you'll see I'm in desktop, so let's say I want to go ahead and deploy a Labtainer. So I'm going to show you this right now, intentionally, just FYI, this was intentional. I did Labtainer nix command. I don't remember if it's command or commands, but you see how it says Labtainer command not found? This goes back to what I was mentioning about this particular executable, because this is going to execute the Labtainer framework, and then this is the argument that pulls this necessary lab Docker containers. But this Labtainer executable is not in the directory or path right here. So I'm at desktop. Well, if I don't know where to go in order to, find this, again, I could use the which command. Sorry, it's not finding it. What I would recommend doing is opening, this is the simplest thing to do because we set it up so that it will always go to this directory. So once you go into, once you pull up a fresh terminal and you go into the desktop Labtainer-student, this is where you can execute Labtainers. It's not going to let you execute a Labtainer environment anywhere else. So we're going to go ahead and try to execute the nix command. I don't remember if it's command or commands. Try commands. Yeah, it's commands with an S, I'm sorry for that. So Labtainer nix-commands. So as I type that, it's going to go ahead and pull up and create those Dockers, or those containers rather. All right, again, if you want to see the prompt inside of this window, if you remember from yesterday, you see the lab manual is at, I can control click and open the link here so that I have it in my same VM. So now I have the lab prompt here. I'm going to shrink that down a little bit so I can side by side what I'm doing. And then I'm going to drag this over. It's transparent, so that's not too bad, but you can just resize this to whatever makes sense for you. And then once I press enter, it's going to start my lab up. Again, you'll see I have this Docker container. This is where you will conduct your lab. This is simply the terminal that's running that lab container for you. So inside of student at nix commands is where you're going to be conducting your lab. And if you, again, you can side by side like this, or if you have dual monitors, that might be easier for you. The scroll on my mouse is super sensitive, but you can see that the nix commands lab is going to walk you through this. So this is going to take you through several things that I demoed today, but it's going to have all of the information about these different commands listed out. So If these are things that you're very familiar with, you've used them before, then I'm sure that much of this you can just skip through. But if this is your first time in Linux, or you are just new to Linux, I recommend going through all of the commands in this lab and reading them thoroughly to understand what you are doing or looking at. This is going to take you through things such as navigating the file system, printing, using different types of privileges such as sudo or su. It'll also help you look at file privileges, so who owns a file, who can read or write to a file, things of that. It will also talk about you'll manipulate your bash rc file, which is going to be something that is specific to how your terminal reacts, changing privileges and so forth. You'll also look at process management. So much like on a Windows computer, when you open your task manager, you have processes running in your Linux computer. Managing and looking at those processes and being able to identify or stop them, such as when you use the task manager and you stop a process. The kill command is how you would shut down, stop a process that might be frozen, for example. So again, I will let everyone go and start this lab up. What we will do is we will resume at 1300 today.
1 o'clock.
1 o'clock, sorry, that's military time for all of you. It's 1 o'clock. 1 o'clock, everyone's going 13. Yeah, so 1 o'clock is when we're going to come back. So you have until from now until then to explore the Linux commands lab. Get familiar with the Linux environment. Once you're done with the lab and you issue the stop lab command, and I'll demo that, you're going to issue that here in the terminal where you started the lab. It's going to tear this down for you, so you're good to go there. You can also simply explore the operating system on your host machine. I do recommend you don't start doing crazy things, changing things, whatever, because we don't really want to rebuild your environments in the middle of training. But again, you can do things like open up Wireshark, do things like wget, grep things. All of these are going to be harmless and something that you're absolutely welcome to do to get more familiar with your operating system. So I'll stay online for a few minutes so that we can collect any questions or issues from the live chat. And after we collect those questions, see if there's anything we can help with after a few minutes, we will go ahead and pause our live lecture stream and ask you to return at 1 p.m. ready for our next stream session with Miss Nicole. Again, you'll find that particular URL. For the unlisted live stream on the agenda as well as inside of Canvas. It will not be the same network or URL address as this stream. It will be the stream that is specified for this afternoon's lecture as found on the agenda or inside Canvas. So if we have any questions, please send those to us through chat. And we will be available. The chat will be there for you to ask questions. If you have any really serious issues with your Range account or Range VMs, again, please contact our Range director. Let him know what your issues are, and we'll see how we can facilitate that.
Go ahead.
So we had a question in our chat as to whether you should have internet connection on your container. I don't believe that this one requires that. So basically it depends on the container. So your host operating system obviously does have internet connection, and it always will. For the containers in your labs, some of them will have internet connection based on the tasks that you need to do. Some of them will not. I don't believe that the Nix commands lab has internet access because it doesn't need it. But again, for anything that you need internet access for, it will be provided. So if there is something inside of that lab that would require the container to access the network, it will be automatically already bridged to give you that access. I don't believe that is the case for the Nix lab, but we'll go ahead and take a look. meaning that if you needed to access the internet for one of those labs where you're in a container and it doesn't have access to the internet, you would want to pull open a new terminal on your host operating system and do whatever you felt like you needed to do, or open up Firefox to check out a resource or something of that nature. To check it, I'm simply going to ping out to Google's public DNS. I do have it, so that's great. This is one that does. I know that tomorrow you will have a couple labs with me in the morning, and I will make sure that I take note of those and give you a heads up. One of those labs does have internet access from the container, one of them does not. So in this case you do, which means you could actually do your wget or curl command on the container if that command or utility is installed, but I don't know that it is, so we'll go ahead and look. It is, of course, something that you can do from your host. Yeah, so you see here where it says suwget command not found. So for this particular lab, the nix commands, that's not something that the lab goes over. So you won't be able to run that inside of your container, but you can do it from another terminal window on your machine. All right, so we'll go ahead and end our live stream, and we will resume at 1 p.m. and you'll be with Miss Nicole Cliff, and she'll be taking you through alerting, snort, and traffic analysis with TCP and Wireshark. So this afternoon is going to be very fun for those of you that are familiar with Linux and are thinking this is very boring and I'm not going to learn anything. Trust me, this afternoon is going to be a lot of fun. And this was just to get everyone leveled and baseline to make sure that everyone is comfortable enough using our environments as we move forward. And if you need support, we're going to be here for you, but this afternoon should be a great time. So we look forward to seeing you then.